normally faint and elusive, the Medusa Nebula is captured in this striking telescopic image. But this nebula is not just a breathtaking sight. It is the remnant of a stellar explosion that occurred thousands of years ago. Today, we will dive into its details, exploring its origin, structure, and the secrets it holds in the depths of the universe. We will wonder how it may have formed, what it reveals about our galaxy's past, and what its ultimate fate might be. The Medusa Nebula, officially designated as IC443, is located in the constellation Gemini, about 5,000 light-years away from Earth. This distance is significant because it means that when we observe it, we are actually seeing it as it was 5,000 years ago, due to the time it takes for its light to reach us. Its popular name comes from its appearance, an arched emission ridge with filaments of gas and dust hanging like tentacles. As if floating in an ocean of gas and dust, its filaments extend into space, rippling like tentacles caught in the cosmic current, resembling a jellyfish in the water. It is interesting to note how many nebulae are given names inspired by familiar shapes on Earth, making them easier to recognize and study. However, IC443 is fainter than other, brighter nebulae, making it a challenge for amateur astronomers trying to capture it with non-professional telescopes. Near it, we find the star Eta Geminorum, which is part of this celestial region and serves as a reference point for locating the nebula in the night sky. What makes the Medusa Nebula special is that it is a supernova remnant. Around 30,000 years ago, a massive star reached the end of its life cycle and exploded in a supernova. This violent explosion released an immense amount of energy and material into space, creating a shockwave that is still expanding and shaping the nebula. The remnants of this explosion interact with the surrounding interstellar gas and dust, creating the stunning filamentary structure we see today. But how do we know it was a supernova? Astronomers have detected spectroscopic signatures and characteristic shock waves that reveal its catastrophic past. Additionally, the expansion speed of the filaments gives us an idea of the time that has passed since the original explosion. One of the most fascinating aspects of the Medusa Nebula is that it emits light across a wide range of wavelengths, from radio waves to X-rays. This emission comes from ionized gases and the interaction of expelled material with the interstellar medium. Telescopes operating in different spectra have allowed us to reconstruct a much more complete image of this nebula than our eyes could perceive on their own. Its filaments are composed primarily of hydrogen, but also contain other elements such as oxygen and sulfur, which glow in different colors when ionized by the nebula's energy. This phenomenon is similar to the vibrant colors seen in Earth's auroras, but on an immensely larger scale. At the heart of the Medusa Nebula lies a pulsar, the remnant of the collapsed stellar core. A pulsar is a highly magnetized, rapidly rotating neutron star that emits beams of electromagnetic radiation. This pulsar is similar to the one found in the famous Crab Nebula, another well-studied supernova remnant. The fascinating thing about pulsars is their precision. They spin at extreme speeds and emit regular pulses of radiation, making them natural cosmic clocks. Next to the Medusa Nebula, we find another stunning structure, the Emission Nebula Sharpless 249. This region, filled with ionized gas, is located at the top of the Medusa Nebula's image and enhances the spectacular cosmic landscape. The study of these nearby nebulae helps us better understand how supernova explosions impact their surroundings, and how the expelled material can influence future generations of stars and planetary systems. Although the Medusa Nebula now offers us a breathtaking spectacle, its evolution continues. Over time, the ejected material will keep dispersing into space, merging with the interstellar medium. Eventually, these remnants could become part of new stars and planets, continuing the eternal cycle of life and death in the universe. Observing nebulae like IC 443 provides us with valuable insights into the dynamics of the cosmos and how the elements that make up our own planet were once forged in similar explosions. The story of the Medusa Nebula reminds us of how dynamic and fascinating the cosmos is. Every star, every nebula, and every supernova tells a tale of destruction and rebirth. Who knows? Perhaps the elements that once formed this star will eventually become part of a new planetary system, or even life elsewhere in the universe. The universe is constantly evolving, and every celestial object has its own story to tell. I hope this journey through the Medusa Nebula has been as fascinating for you as it has been for me. Thank you for watching this video until the end. I would love for you to leave in the comments which nebula you would like me to examine. If you enjoyed it, don't forget to leave me a comment and subscribe. It would mean a lot to me to build a community of people who love astronomy as much as I do. On the other hand, if you want to have the best space images in your home, you can get them from our website. There, you'll find many images to collect and enjoy for a lifetime. Plus, you'll be supporting the creation of more videos like this one. Shipping is completely free worldwide, so I invite you to explore our catalog. The link will be in the description. Thank you so much for your support. See you in the next video.